this video, we will learn how to solve a problem in fluid mechanics, particularly in fluid flow measurement. So we have here this problem. A stagnation tube with a diameter of 2.15 millimeter is inserted into a flowing water that has a velocity of 13.3 meter per second. If the deflection on the water manometer is 9.14 millimeter, determine the pressure drop from the manometer and the ratio of inertia force to the viscous force. The air has a kinematic viscosity of 1.4 times 10 raised to the power of -5 square meter per second. So we have listed the known values here. The diameter of the stagnation tube, which is 2.15 millimeter, converted into meter, it is 2.15 times 10 raised to the power of -3 meter. And the velocity of the flowing water, which is 13.3 meter per second, and the deflection or the turning aside of the water in the manometer, which is 9.14 millimeter, converted into meter, which is 9.14 times 10 raised to the power of -3 meter, and the kinematic viscosity of the air, which is 1.4 times 10 raised to the power of -5 square meter per second. So what we are going to determine here is actually the pressure drop and the ratio of inertia force to the viscous force. So this ratio of inertia force to the viscous force is actually the Reynolds number. So Reynolds number, so we are going to solve first for the ratio of inertia force to the viscous force. So solving for Reynolds number is equals to the velocity times the diameter of the tube all over the kinematic viscosity. So plugging in the values, since we already have all the values, the velocity 13.3 meter per second times the diameter of the stagnation tube, 2.15 times 10 raised to the power of -3 meter, all over the kinematic viscosity of the air, which is denoted as mu. So 1.4 times 10 raised to the power of -5 square meter per second. We will get that it is unitless, since all of the dimensions or the units here will cancel out. We will get that the Reynolds number is equals to 2042.5. So that is the ratio of the inertia force to the viscous force. Now we are going to proceed in determining the pressure drop. So we know that pressure is equals to the gamma, which is the specific weight of water, times the height. So we are actually looking for the pressure drop. So we are actually looking for the change in pressure. So change in pressure is equals to gamma times the change in the height. So we have the deflection in the water manometer given, which is 9.14 millimeter. So we can just actually plug in all the values, since the specific weight of water is already known to us. So we have the specific water, which is 9,810 Newton per cubic meter, times the deflection of the water in the manometer, which is 9.14 times 10 raised to the power of -3 meter. And from that, we will get that the pressure drop is equals to 89.66 Newton per square meter. And this Newton per square meter is actually Pascal. So the pressure drop is actually 89.66 Pascal. So this is the solution for this problem.